Hey guys, what's up? Welcome back to one new video. In this video, we'll learn what learn. We'll see how we write a program in C, Turbo C++ that basically checks whether a program is prime or not. We will appreciate the logic which is imparted in it. Really cool. Sometimes looking at somebody's solution really makes you so much hyped. So this was one of them. It's a book solution which I did not like because I thought it's hard, but it's kind of easy. Let's go. So I've made a file named prime chi prime number checker, whatever. Like always, let's start with hash include hash in c abeas include zero. You can, if you want, you can give space here or as much space as you want to, I guess. But I like to just concate them together. So we'll use our favorite thing hash include conio.h conio.h to use clear screen and get ch in some of the programs. Starting with void main. Herein we will be declaring our variables int, and our first variable's name is num, and I for indexing. For our num is for why, and I is for indexing of our for loop, and then we'll set a flag variable and we'll set it to 0. 0 means it didn't go through any change. 0 means it's a prime number. So now we will create a printf statement like always. Enter a number, close it, and scanf, and set it to array percentage d, comma, and percent num. Same num here. They're assigning it some value, which the user will input. Okay, cool. Now we'll now assigning is done. Now we'll create some loop. We'll create some logic. That's for loop. For I is equals to 2. Okay, I have some thing to try. We'll set 1 also, but we know why 1 will always give us false result. I'll show you why. I is greater than equal to num divided by 2 I plus plus in this case. So let's set it here only. Yeah. So I want to make changes here as well. So I feel like this line is unnecessary or something. Maybe I don't understand the logic yet. Right. Anyways, I wanted to try if the num is equal to 2, will it get some weird results or something? I don't know. So for if num modulus I, in this case is 2 for the first loop, is equal to 0. That is completely divides, divisible by a certain number. That means it's not a prime number. So we'll set flag equal to 1. Semicolon, close. So the for loops also ends with it. So if flag is equal to 1, then we'll say print f, let's say it is a prime. Oh, it is not a prime. Not a prime, sorry. Not a prime number. Simply else print prime numbers. Indeed. So I don't like this. Indeed. Prime number indeed. So okay, so we'll use clear screen here. CLR clear screen और यहाँ पे हम लोग यूज करेंगे ch. Okay, run it. Enter a number. So we'll use, let's use some number 4, not a prime number. Cool. Ta-da. We'll use 3, a prime number indeed. 1, a prime number indeed. So what the fuck it works in 1? अब एक्चुअली 1 में कैसे चल रही? 1 में रन ही नहीं किया. Oh, flag का flag रह गया बे. अच्छा, when we set num equal to 1, then you might be thinking that 1 divided by 2 is less than 1 or less than 2 also. So why is it not running? Why? That the thing is, the loop didn't even enter in the first place. It's always out of it. So it just flag is 0. Just flag is 0. It's a prime number. Cool. Let's try with minus numbers. Like minus 56. A prime number is. What the fuck? ये कैसे भाई? Prime number होता है क्या? Minus numbers are prime numbers. Is minus 56 a prime number? A prime number is a whole number greater than 1. Oh. So, so, so. So we'll set a certain value right now. That is to make our program a bit more robust. Creating robust programs take a lot of time. We don't have time, but for God's sake, let's do it. Let's else if and else. Oh, if not else. If num is num is smaller than 0. We'll just say entered number is is not prime nor composite. Neither prime nor composite. Okay, so let's run. Let's run. Have a loud A. Let's run. Minus 33. One. Is 1 a prime number or composite number? So 1. So let's run. 1. 2. Yay, yeah, bro, yay, yay. Nice. So I wanted to change here. क्या हो गया भाई? टेंशन हो रहा है कुछ? भाई साहब. So, as I told you, it could be simplified here. I think the previous written code was there to fix the time complexity of this, that it might not run through many processes that it might save some steps, but you can write this also and it will work as well. So you now understand why I was set to 2. If it was set to 1, for example, it will set all the numbers as prime numbers except the minus numbers. What do I mean by that is, like, let's say 2. What the fuck? ये क्या आ गया? ये क्यों आ गया बे? 1 बे, ये क्या हो गया? हाँ, तो हाँ, सब नंबर को नॉट अ प्राइम नंबर बोलेगा, सही बोल रहा हूँ मैं. तो इट विल से ऑल द नंबर्स आर नॉट प्राइम नंबर्स. फॉर एग्जांपल, लेट्स से 11, a prime number, is not a prime number. Let's say 4, which is not a prime number, will also say not a prime number. So we should have a 2. Why 2 is written here? Because 2 is written here. Why? Because if it is 1, if you divide any number by 1, it will always result into 0 remainder. Always the remainder will be 0. But when you divide a certain number by 2, in that case, it will not. In that case, if it is less than that, then it will always run. Oh God! अब ये समझ में आया कि greater than equal to क्यों लिखा रहता है यहाँ पे. Okay, let me just explain why greater than or less than or equal to num क्यों लिखा है. For example, like factors of a number in maths. Let's do it. Let's Google it actually. Example here. Let if you closely notice the factors of a number, it is 1, 2, 3, and straight away 8. If you see, this is 8 divided by 2 is 4. There is no number in between, right? So, so to check if a number is divisible or not, we should check divisible by a certain number or not. We should check till half of it or equal to half of it. It is still here. So that is why. Otherwise, it will check for 1, 2, 4, and it will continue checking. It will it in this case here, this will iterate. This will keep on iterating. Like for example, if a number is divisible by to check if a number is divisible by 4 or not, so it will run with 2. It will run with 3. It will run with no. If it completely runs with 2, then it will stop calculating further. So, but if it is just less than num, that is this case, it will go for 3 and then it will stop. Oh yeah, written num divided by 2, right? ये था ना? Divided by 2. Yeah. So yeah, that's what I was saying. I don't know how to check that. How do I show this? But this is why it is there. But num by 2 will also work. It was cool, interesting case. So let's try more. 1, not a prime, not a prime. So nice, nice. It's long video.